Silent, mysterious, and endlessly captivating, the eyes of owls have fascinated humans for centuries. These birds of prey, perched high in the hierarchy of nocturnal hunters, owe much of their legendary prowess to their extraordinary vision. But what truly sets owl eyes apart? Their structure, placement, and function are masterpieces of evolutionary design, perfectly sculpted for life in the shadows. First, let's consider the sheer size of an owl's eyes. Proportionally, owl eyes are enormous compared to their heads, so much so that if a human had eyes comparable in scale, each would be the size of a tennis ball. This remarkable size permits more light to enter, which is especially useful when hunting under the pale glow of a crescent moon or the dark of a forest night. Unlike humans, whose eyes are round, owl eyes are more tubular, extending far back into their skulls. This unique shape increases the retinal surface and the number of light-sensitive cells called rods, giving owls superb sensitivity to dim light. Despite their impressive size and structure, owl eyes have a limitation. They cannot move within their sockets like ours can. To compensate, owls have developed an astonishing ability to rotate their heads up to 270 degrees. Flexible neck vertebrae, 14 compared to the human 7, allow these birds to look over their shoulder or down behind them with ease, scanning their surroundings with those unblinking, mesmerizing eyes. Peer into the gaze of an owl, and you'll encounter eyes that seem almost otherworldly, sometimes golden, sometimes deep black, and in some species, a striking orange. The color of an owl's eyes isn't just for show. It hints at their preferred hunting habits. Owls with dark, almost black eyes, like the barn owl, are masters of the night, using moonless hours to stalk their prey. Gold-eyed owls, such as the great horned owl, tend to be crepuscular, active at dawn and dusk, while species with orange eyes dwell somewhere in between, keenly attuned to the shifting tapestry of twilight. The retina of an owl's eye is densely packed with rods, the photoreceptor cells that function best in low light. While humans see finer detail thanks to a greater concentration of cones, cells responsible for color and sharpness, owls are equipped to see their world in shades of shadow and movement. Their color vision is limited, but their ability to detect motion, even the faintest rustle of a mouse in the grass, is unparalleled. But there's more to the story than just catching light. Owls possess binocular vision. Both eyes face forward, giving them superb depth perception and allowing them to pinpoint the exact location of their prey. This three-dimensional view is crucial for calculating distances during those silent, swooping hunts. And then there's the nictitating membrane, a translucent third eyelid that sweeps across the eye like a windshield wiper. This membrane moisturizes and protects the sensitive sphere while preserving vision, crucial for creatures who must keep their gaze sharp through dust, wind, and the frantic struggles of their prey. Of course, these evolutionary marvels are only one part of the owl's sensory arsenal. Their keen ears, sometimes asymmetrically placed, help triangulate sound in perfect harmony with their vision, creating an unstoppable combination of sight and hearing. Majestic, mysterious, and perfectly adapted, the eyes of owls are more than just windows to their souls. They are instruments honed by millennia, tools of precision that have ensured the survival of these beguiling birds across continents and ages. Next time you catch the glint of an owl's eyes in the moonlight, remember, you are witnessing millions of years of nature's ingenuity, focused in a single, breathtaking stare.